Hello everyone, welcome to ArcGIS channel. In the previous lab, we provided an overview of ArcGIS Pro and made a map based on base map, which was not that informative. Today we're diving into ArcGIS Pro to create some commonly used maps together using the CDC's Social Vulnerability Index, or SVI, as our own data. So SVI is a powerful data set that helps you identify communities that may need extra support during or after emergencies. So in this tutorial, I'll walk you through obtaining, preparing, visualizing SVI data using ArcGIS Pro. So we will learn how to create a Choropleth map, Bivariate map, dot density map, proportional maps, and so on. So in GIS Labs folder, I'm going to create a new folder. I'm going to store everything in this folder to _SVI, so which is lab 2 and it's about SVI. The next thing is that I need to get the data, get the SVI data. So open up Google and type CDC SVI. So after that, select the first link, Social Vulnerability Index, Place and Health, ATSDR, CDC. So click on that, and here it provides some information. As I mentioned, social vulnerability refers to demographic and socioeconomic factors. So it consists of multiple variables like poverty, access to transportation, crowded housing, that affects communities that encounter hazard. Okay, so it can be natural or human-caused disasters. And also it provides the sources of information and information about the history of the data. And the most important thing is that this CDC consists of 16 variables in 4 different themes. Okay, so for example, we have socioeconomic, household, racial and ethnic minority status, and housing type. And each one, there are multiple variables. For example, poverty, unemployment rate, housing cost burden, and so on. Okay, and also changes over time. And then, so what is the implications of using SVI in action? For example, in public health, officials can use the SVI to identify areas in need of emergency shelter and estimate the amount of supplies needed. Okay. And so you can get the data at 2 levels, at the county level and also at the census tract level. Okay, so if you select SVI data and download, data and documentation, select that. So as you can see, you can get this for different years. I'm going to select this, for example, for 2020. Geography can be for the entire United States, Puerto Rico, and different states. I'm going to select South Carolina. And as I mentioned, you can get it at the census tract level or county level, but for the sake of simplicity, I'm going to just select it at the county level. So you can get it as CSV file and also as Esri geodatabase, so you can easily add that into ArcGIS. But CSV file, you can also work with the CSV file, but it most of the time requires some data preparation that we will talk about that in the next lab. So I'm going to select Esri geodatabase and then OK. So it creates a zip file. So zip file, ArcGIS cannot read the zip file. What you have to do is that, first of all, extract the zip file in the lab 2 folder, and then you are able to open it in ArcGIS Pro. Okay, so I'm going to find this file, and then I'm going to paste it in GIS lab folder, lab 2, paste, and then I am going to extract all here and then extract. So whenever we get the data that is zip format, you have to definitely, first of all, move it to the corresponding lab and then extract it. So when you have the data, when you download the data, SVI data, the next step is that you need to load it into ArcGIS, right? So in ArcGIS Pro, so let me make a project. So I'm gonna call this SVI, and I'm gonna save it in lab 2 folder, GIS labs, and then OK and OK. So the way that you can load the data into ArcGIS is from map menu, and then as I already talked about, that is using add data. So click on add data and then go to the lab 2 folder, which is here, GIS lab SVI, and here you can, so it's a file geodatabase and then feature class, but it doesn't matter, just select this file and then OK. So as you can see, the map of South Carolina at the county level has been added. Okay, so it's a single color map. It's not representing anything, but within this map we can get the SVI information. So the first thing is, so where can I see the attribute information? For example, poverty, housing cost burn, unemployment rate, and so on, right? So in order to see the attribute information or information that are non-spatial, like numbers or like demographic characteristics, you have to right click on the layer in the table of content. As I mentioned, when you add a layer, it will be added to the table of content or contents. Right click on that and open the attribute table. So when you open up the attribute table, the first thing is that it's a table which consists of some columns, some rows, and each row, also called record, each record shows one feature on the map. Okay, so for example, if I select Charleston County, double click or just one click, you can see the corresponding county will be selected on the map. So if I select multiple counties, the corresponding counties will be selected on the map. So how many counties do I have? So 46 counties. 4 out of 46 counties have been selected. So each record shows one location on the map or one county on the map. So if I want to clear this selection, you have to click on clear here. Okay. And if I want to select something on the map, so as I mentioned, if you click on select here in the previous lab, and then you are able to select something, the corresponding record on the attribute table will be selected. In order to see that, you have to click on show selected record. So that's Newberry County. Okay, so if you also, it is here. So you can select like multiple, for example, counties, and also the corresponding will be selected. So if you select here, here will be selected. If you select here, in the table will be selected. And to remove it, to clear selection, clear selected. Okay, so that's the rows. So each row represents one feature, and the column, each column represents one field or one characteristic. Okay, for example, we have ST abbreviation, which is South Carolina. We have ST county. So this is the code for each county, which is a unique code, which is also the FIPS or federal number, I think. Yeah. So this is FIPS, a federal number or unique code. We will use it a lot for joining in the future labs. We have the name of the counties, we have the location, and we also have, so these are information about the SVI. So we have area, a square mile, estimated total population. I think this one is, so in order to better understand what this information represents, you have to look at the documentation. If you go back to the SVI, SVI data and documentation, there was documentation here. And for example, for 2020, the data that we downloaded. So there are more information about like what the poverty explains, what is the actual definition of poverty, unemployment, and so on. So for each one, they have provided detailed information, but here, this is important that, for example, we didn't know what is EHU, it's housing unit estimate. So it's estimate of housing unit. So you have to look at this. You have to look at the documentation to understand what this represents. So unemployment rate, so this is unemployment rate. This is poverty 150. So some of them are start with EP, which represent estimated percentage. So some of them are just actual number, but some of them are percentage. And I think this is much better for us to represent. Okay, so I would like to, for example, make a map based on EP poverty or EP unemployment rate. Okay, so now we know what each field represents, so we are able to map it and understand what that means. So, but before that, so let's go back here. So I would like to label this county so I understand what is the name of each county. So how can I label each feature on the map? I have to right click on this in the table of content on my data and then click label. So as you can see, all of the data have been labeled as 45, which is not interesting. So when you click on label, as you can see, another tab, labeling, has been added. So click on labeling. So the reason it's 45, it's because it is being labeled based on the field ST. So if you open up the attribute table, there was a field ST45, right? So that's why it's been labeled 45. So I'm gonna label it based on county, so you can see the name better, right? So if I select the field county, so now we can see it's been labeled based on the county, which is much more informative, right? And if this font size is large, you can make it smaller, right? Like this. And sometimes, so here it's okay, but sometimes you have some linear feature roads. So it's important where you would like to put or place the label. So for example, on the road, below the road, above the road. So you can look at the label placement and select other options. For polygon here, it looks perfect. I don't change it, but for, I don't know, like as you can see, there are some changes, right? For point and line features, sometimes you need to, like for example, here it's another type of labeling. You can use other labeling options, okay? All right, so I'm going to just select this one. So the next thing I'm gonna do is, so after having the labels, I would like to color code this map based on like unemployment rate, okay? EP unemployed, right? So how can I do that? How can I say that, okay, so here we have unemployment rate higher or lower, and color code or color shade this map or create a Choropleth map. So in order to create a Choropleth map from any layer like SVI for 2020 or any other layer, the first thing that you have to do is that you have to right click on that and then select symbology. So here it's obvious that we have used a single symbol, that's why the color is also yellow. So I want to create a map based on unemployment rate, and in unemployment rate, EP unemployment rate, according to the documentation, I have to find that field and create a map based on that. But the unemployment rate, if you look at that, definitely it's a number, right? So for the number, you have to use quantities, right? So all of them, as you can see, everything is based on the rate is a number, right? So what you have to do, you have to select graduate color because it draws quantities using graduate color. So it's for quantitative variable. So when you select the graduate color, it creates a map, right? But the question is, but the problem is this map is not based on unemployment rate. It's based on area square mile. So I have to select EP unemployment rate, which is here. So now this map shows the unemployment rate in the South Carolina. For example, we have lower unemployment rate between 3.7 to 4.5 in Berkeley County or Charleston County, right? So, and also you can change the color scheme. You can use a better color, for example, maybe. So a color that I can easier distinguish the classes, right? So maybe this color, or maybe color that like this, and or no, like this. All right, so the next important thing is that, so as you can see, the range of the value of unemployment rate is between 3.7 to 12.9 in South Carolina, okay? So the question is how the classes have been defined, okay? What is the classification technique that they use to define the cutoff value between 4.5 above, between 4.5 and 5.7? Why it is not 3.7 to 4.6? That's a question. So how they define the cutoff values, how they define the classes. And there are a variety of methods for classification. For example, here they have used natural break. That's the default classification technique. So natural break, what happens in natural break is that, so let's look at the histogram. So natural break finds the largest gaps. So it's between 3.7, 12.9, right? Finds the largest gaps in the histogram and defines the cutoff values when there are the largest gaps between classes. So it tries to minimize the variance within the class and maximize the variance between the class. So that's the definition of the natural break classification. So it naturally finds the gaps, naturally finds the breaks. So if you want to have the same frequency, the same number of features, okay, for example, 5 in this class, 5 in this class, 5 in this class, and so on. For example, here it's going to be like 9 times 5 is going to be 45, which is almost 46. Okay, so if you want to have the same frequency in each class, so the technique is called quantile. So here we have quantile. Distribute the observation equally across the class interval. So you have the same number of features. When you select quantile, you will get different result. But as you can see, the number of the features in each class is almost, for example, if you count them, is almost the same. It's like 9 per each class. So that's quantile. So another one, so also if you look at the histogram, it doesn't show the exactly, so but it's like 9 here, 9 here, and 9 here. Okay, so here, for example, it's find a cutoff value that you have almost 9 observation, because here it shows the frequency. So another classification technique is equal interval, and as the name says, the interval is equal. Okay, so for example, between 3.7 to 5.5 is the interval is the same as 5.5 to 7.3, right? If you also look at the histogram, you can see the intervals are equal in the equal interval classification. As you can see, you can get totally different result based on equal interval. So you may say that, can I manually define the classes? Yes, you can definitely manually define the cutoff value. So I think there are, if you, like here, if you can easily define the cutoff values. So you can put the cutoff values here. For example, I want to have 3.7 to, for example, 5, right? And then 5 to 7. Look at the labels here, like 5 to 7. And I want to have, where was that? Classes. 7 to 8. And then 8 to 10. And I don't change the last one, okay, because so it's going to be 10 to 12.9. So you can manually find the classes, or you can use the histogram and just manually change the classes like this. So you can, so as you can see, when I change the cutoff value, I can get different maps. So another classification technique, if your data is normally distributed, is the standard deviation. Okay, so if I select the standard deviation, so each class size is almost one standard deviation, between 0.5 to 1.5 standard deviation, between 1.5 to 2.5, 2.5 and above, or negative 1.5, negative 0.5 to 0.5. So the standard deviation is 1 for each of these classes. So that's is used if your data has a normal distribution. You have to look at the histogram, and if it has a normal distribution, you select that. So another classification technique is called geometric interval, and geometric interval is based on the mathematical functions, and it is helpful when your histogram is very skewed. Okay, and if you want to, for example, reduce the influence of extreme values or outlier, you can use geometric interval. So that was about different type of classification techniques, and I'm going to just select the natural break classification. You can also change the number. Why it is 5? You can also have like 6 or 7 or 10 classes, as you can see. Okay, so you can easily change the number of the classes, increases or decrease the number of the classes. So I would like to select just 5 and natural break to find the largest gaps for me. And also, again, I can change the color scheme to better distinguish the classes. Do not use the color scheme like this, that it's hard to distinguish the classes. Okay, so use the color scheme that you can easily distinguish the class. If you, for example, select something like, I don't know, maybe this, and you want to make some changes to some of these colors. So you're happy generally, but you want to, for example, have this as like dark brown, something like that. So you can easily do that. You can right click on here and then, for example, select the last one as dark brown. Okay, so if you want to have this as light pink, so again, you can do that, or you can maybe, I don't know, maybe this is not a good option, but maybe like having white, showing this one to have a very low unemployment rate. So you can easily change, you can manually make some minor changes if you want. You can pick your color as well. So I have selected this color. So once you're happy with your map, similar to the previous lab, as I mentioned, you have to go to the Insert tab. So let me also get rid of this worldwide background map. And Insert tab, New Layout, select the paper size, and then from Map Frame, select the map, draw a box, your map will be added. You have to add north arrow scale bar. If you want to zoom in, you have to right click and activate this, and then you can easily zoom in. You have to press positive or negative sign or you zoom in with the mouse, right? And sometimes it's not easy. So, or if I want to make this horizontal, I could, for example, select horizontal letter. So, and then here I could, so let me remove this one, and then add the map again. So maybe I think horizontal makes much, seems much better. All right, so from map frame, draw a box, and here is the map of the South Carolina. If I want to, for example, zoom in, so I have to, first of all, I have to activate this, and then I can close this. And also, if I want to pan again, I have to activate it. Okay, so for example, use Explore and pan my map, right? Close this. So it looks good to me, South Carolina. If I want to get rid of this border, select this one, and then go to this one. As you can see, it's a frame. Select, or you can right click and properties, and then go to the third tab for map frame. And here for the border, instead of black, I'm gonna just remove it, no color. So you can remove the border if you want, but I think it's better to just keep it. And what can I add is, for example, I can add north arrow, I can add scale bar, I can add, yeah, it looks good, everything, the values are good. Another thing that I can add is I can add legend. Okay, so for the previous lab, I didn't have any legend, but here I'm gonna add the legend. So in order to add the legend, and then select this one, and then draw a box for the legend. And here is the legend for my map, but it requires some modification, as you can see. For example, I don't want to see the word legend because it's legend, right? So I double click on this, and here you can see legend, or I can right click on properties. I'm gonna say that for the first step. I'm gonna say that, for example, uncheck the word title. I don't want to have a title. Okay, so the word legend has been removed. And also from legend items show properties, I don't want to see the layer name, SVI something, right? So I'm going to uncheck this. For EP unemployment rate, so what can I do is that I can, if I want to change this to, for example, unemployment rate, so and then within the parentheses put the percentage, so I can change it from here. So if you have one click, a single click, and here type unemployment, right, percentage. So now if I double click, it's much nicer to have this, right? So another problem here I can see is there are so many zeros, right? So how can I fix that? So in order to fix this, it's not about legend, it's about the symbology. You have to go to the symbology tab, and the last tab for the symbology, advanced symbology, because it's about symbology, symbol, right? So here we have format label, and there are 6 for the number of the digits after this. So I'm gonna remove this to 1, just reduce it to 1. So let's see what happens. So as you can see, this is much better compared to having extra zeros, right? It's much readable, and also it's being updated here. So you can also have, so here we had it as a numeric number. You can also have it as a percentage, right? So for example, if I select percentage, it shows it as percentage. I don't know why it didn't apply for all of them. I don't know, it's weird. But you can also have it as a currency, like dollar, or you can have it as fraction, like something like that. So it depends on the type of the problem, but percentage and so decimal, I'm gonna have it as 1. Okay, so here it's better. So you can see that, so the values, unemployment rate, percentage, you can see the values, it's much better. So another thing you can add is, so let me select everything. It doesn't allow me to select everything, and then probably move the entire map down to put it in the middle. So I'm gonna have a title. I'm gonna call this unemployment rate here, unemployment rate in South Carolina 2020. So and also I'm gonna have this larger, for example 24. I'm happy with the font. And then so I have unemployment rate in South Carolina, I have north arrow, scale bar. I can add, for example, credit, right? So I can, for example, provide, like, for example, what is the source? Okay, source is CDC, right? So I can add this here. Okay, so then last thing is that you just have to go to the share tab, export layout, geotiff. So I'm gonna call this in lab in SVI folder. I'm gonna call this, for example, layout 1 is fine, or unemployment that TIFF is okay. Everything is good. 400 DPI and true color export. And if I go to the SVI folder, I can see that I have created unemployment rate here. I can use it for my publication. It's very good quality. It has 400 DPI. You can increase the DPI, but it's fine for my map. So I can close this. And sometimes you may want to compare 2 quantitative variables simultaneously, okay? So in that case, instead of just using a one single map, you have to use bivariate maps. For example, I would like to compare uninsurance rate and age 65 plus, okay? So I can start building the map from scratch, or another thing is that, as you remember, in catalog pane, I can copy the map, right? So if I go to the view catalog pane, I can see my map is here. So I can duplicate this map, and I'm gonna call map 1 as like bivariate, and double click on bivariate. So here's my map. So I would like to compare 2 different variables at the same time. So what should I do? I have to go to the symbology tab, and instead of graduate color, which is for one variable, I select bivariate color. So if I want to compare 2 variables at the same time. So I'm going to compare uninsurance rate, or EP uninsured. EP uninsured, this one. And also I'm going to compare it with EP age 65 plus. I want to see the relationship between two variables at the same time. Okay, so EP age 65. Okay, so here's the map. So what can I understand from this map is, for example, in this area in Florence County, we have low uninsurance rate because this is pink, shows low. And also it has very low age 65, right? Both of them are low. But for example, in this county, I don't know, like this one, Allendale. So we have high, both of them are very high. In Berkeley, we have a low, medium uninsurance rate here, but we have like again, medium, low of the age 65. So that's how we can interpret bivariate map. So when you have two variables, you would like to compare them at the same time. So you may say, so what was the technique for creating this map? So the default is quantile because they want to have almost the same number of the observation per each of these pixels, okay, per each of these cells. So I want to have for low, high, the same number of observation and also the other cells, right? So, but you can also again have equal interval, natural break, and so on. And also we use 3x3 grids. You can also increase the number of the grids, like 4x4. Okay, probably low, medium, I don't know, low, medium, above medium, and then high, and so on, right? So that's how we can create the bivariate map. Also, you could change the color ramp if you want. So another way to compare multiple variables, but using charts like pie chart. So for example, I want to compare, I don't know, EP uninsurance rate, EP age 65, EP POV, multiple variables, not just two, is using charts. So if you, so again, I have this map. I can again create them, export this, share it, and so on. Or I can go to the catalog pane. So don't forget to save this work. And then from map one, I'm going to create a duplicate. And here I'm going to say chart or pie chart map. So what happens is that if I double click on here, I want to create a pie chart map. And I have to go again to that symbology. And here select charts. And here I'm going to select pie chart. And so here is just one variable. And I would like to select multiple variable. For example, I want to select EP uninsurance, EP age 65. So EP, and it doesn't matter, EP unemployment rate, EP housing cost burn, right? I can also add more fields. EP poverty. Okay, so here, so maybe this is not a good one. So maybe make this smaller. I think I can change the size. Yeah. Yeah. So even smaller. Perfect. So I can have pie chart for. So as you can see, that there were like problems with the label. So I'm going to turn off the label. So I can have, like, for example, this is you're not comparing the variable here. It's not saying that, okay, so I have higher poverty than higher unemployment rate. But you can compare variables with each other, like one variable over space. For example, in which area we have higher poverty, like you have to have higher share, right? Something like that. In which area we have lower poverty, for example, these areas, right? These areas. So it creates some visualization if you are interested in this type of maps. I'm not a fan of pie chart maps, but that's some option that you can try. So another map that you can create for quantitative variable is dot density map. Dot density map is a very important map that each dot represents some specific numbers to show concentration, okay? So we normally use dot density map to visualize large quantities, okay? For example, I want to show the estimated total population, okay? So I use dot density here, and total population is a very large number, right? So I select E total pop. So as you can see, it shows, it uses some dots to represent that, and each dot, the dot sizes to each dot represents 3,000 people, right? So the location of the dots is not actual location, it's just randomly puts the location on each county, so it's not an exact location, but you can easily see that the higher concentration in the large counties of the South Carolina, right? So in these other counties we don't have large population of the people, but here we have higher. So dot density is a very common technique for representing the variables that have very large number. So another one is graduate symbol. Graduate symbols. So graduate symbols, as you can see, it uses like circles, right, to represent quantities, and obviously the larger circle, the larger value. But here each circle has a range of value, okay, for example, between this value and this value. Or maybe let me show it for estimated, which variable, maybe E total population. So as you can see here, we have higher population in these areas, right? And it has a range of values. For example, for this one, the range of value is between over 300,000 to 500,000, right? So it uses circle to represent different quantities. And this helps to provide a clear comparison between different regions. So another one is proportional. And proportional, it's very similar to the graduate symbols, but it doesn't create a range of values. So let me use the E total pop, but it uses just a single value. Okay, so it's just an approximate value, like 10,000, 50,000, 1 million, right? So it's an approximate value, but again, so that's something for representation. And the size of each symbol reflects the magnitude of data value, okay? The symbols are scaled so that their area is proportional to the value they represent. So for example, this circle, 10,000, right? So the second circle is 5,000, like 5 times greater than this. So, and which shows their values of 50,000. The next one is 2 times more than this one, okay? So the size of each symbol reflects the magnitude of data and is a scale so that their area is proportional to the value they represent.